Putting it out there, the VCE Chem exam is tough. I did the International Chemistry Olympiad for Australia last year, and I still found the exam annoying at best. But there were some strategies that I picked up along the way, so let me share them with you. At the time of filming, it's 2025 and it's only a few weeks out until the chemistry exam. Compared to last year, you guys will have a much more reasonable understanding of the new study design, because you have last year's papers, and so you've got to make the most out of them. The order in which you prepare exams is quite important. The order I'd recommend is first do company papers from the old study design, VCAR papers from the old study design, company papers from the new study design, and finally VCAR papers from the new study design. Now the last two are pretty much compulsory, but the first two are fairly optional, just depending on what workload you want to have in year 12, just balancing all your subjects and whatnot. So the exam starts off with 30 questions worth of multi-choice, in which I'd say you'd want to spend maybe about 20 to 30 minutes on this part at most. Now, there's a few ways to go about multi-choice that'll make sure you go about it a bit more smoothly than what you might otherwise do. The first part is just mark and move. Now, if you look at a question and you think it's going to take some time to do, whether that be because you don't quite understand it right now, or because it's just going to involve a lot of calculations. I mean, it reminds me of one of those questions where it's like, calculate the energy content of like 6 different foods, and you have to like put them all together and then compare them at the end. That sort of question, right? You want to just note down, try to write out a little method that, you know, I can do this to solve the question, and then move on. Because that way, you're spending time on the things that are sort of the easy marks to get. You're moving along, you're not getting sort of like just stuck on the same question for a long time. You see, the goal is to secure the quick marks first. Next, don't just stop at the right answer. If you go through options A, B, C, D, what a lot of people do, right, is they go A looks wrong, B looks right, circle B, move on. But the problem is that a lot of questions are designed to trip you up in a sense, right? You want to be actually checking through, does A, B, C, D, does one of them look perfectly correct and the other 3 look perfectly incorrect? What you really don't want to happen, right, is you go A incorrect, B correct, and then you miss out that C is in fact also correct, and D was the option. B and C are both correct. And so in that case, you're kind of screwed, aren't you? So you want to take your time going over A, B, C, D, all the options. And finally, just watch out for the wording. Now, there will be many questions that are like, well, all of the above, none of the above, not. Just make a note of those, especially during reading time. You want to see if there's any of those like sort of tricks that could get you, such as, well, which one is most likely to happen, which one is most unlikely to happen. Get your mind around those, and that's a lot of marks that you'll be getting back as well. After the multi-choice, we're going to be hit with 90 marks worth of extended response, and by no means, first of all, do you need to get all 90 marks. I think in a previous video about my exam preparation, I talked about me preparing for sort of like a 100 to 120 sort of, you know, mindset, preparing for a chem, and in the end I got 110 out of 120. So by no means do you have to be perfect, or even, you know, get 80% of the marks in an exam. But moving on to some techniques that would help in extended response. First one I'd say is you've got to write what the question actually asks. There are many different verbs that come out in exams: analyze, discuss, distinguish, calculate, explain. You've got to figure out what they're trying to really get you to do there. For example, in a question about discuss, you might want to discuss both the positives and the negatives in the topic. For a question about distinguish, not only do you want to talk about thing A, but you also want to talk about thing B, and then specifically mention where do they differ. Stuff like that, answering the key verbs in the question will make sure that a lot of these extended response questions you end up getting the marks for. The next part is use chemistry language. Now, a lot of examiner reports do say that students miss marks because they're sort of just using generic English terminology. Rather than the rate of reaction increases, they just say it reacts faster or reacts more intensely. You want to be really using the chemistry lingo that you've learned throughout the year. The rate of reaction increases due to a higher frequency of collisions. Something like that is what they're looking for. Words like partially opposed, oxidizing agent. You want to use those instead of using like a violent reactant or something like that. Thirdly, units, sig figs, and conversions really do matter. These are probably the easiest marks to lose out on because it's all at like a flick of a switch, you know? Maybe a question suddenly switches from milligrams to grams or to kilograms and you're not paying attention. Maybe a question has something in 3 sig figs, something in 3 sig figs, and then a little bit of trap, something else in 2 sig figs. You gotta be really paying attention to these small details because they do add up over time. And these are considered probably the easiest marks to, retain because they're sort of simple. We don't want to be making conversion mistakes because it means we've got all the knowledge right, but we've just messed up on the calculation, which shouldn't really be the tricky bit. Also, think like an examiner. A lot of questions are really nicely designed. They have parts A, B, C, D. They have parts A, I, triple I, B, I, blah, 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 right? What's the point of doing this? Why is it not all just like question 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 60 or something like? The reason is because these questions are meant to build upon each other. You're meant to use what you've sort of developed before in the previous questions. So if you're ever really stuck on a question, don't look at it by itself. Look at it in the context of the whole question. What information is there in the answers that you've given in parts C, B, A? What information is there in even the questions of A, B, C? Even the original question prompt that you can use to answer part D. You gotta think like an examiner. And when you have all the information gathered together about a question, it helps you answer it a lot more easily. And finally, check your answers with your gut. This is probably the easiest way to spot if you've made a mistake or not, especially with calculations. You might need to get a little bit of intuition as to like what a correct sort of answer is. I remember on one of my papers, I think I calculated a concentration of like 70 kilograms a litre. I don't know if you know, but a litre of water is 1 kilogram. So having 70 kilograms of something in there was obviously just not correct. When I looked at that, I was like, oh shit, okay, I probably did a times instead of a divide somewhere back before. Check back. It looks like I accidentally multiplied by molar mass instead of divided by molar mass. That's such an easy way of just rooting out any small mistakes that you make. Okay, so the final problem is, how do we answer those really long explain questions? You know, there's like 4 or 5 markers, 3 or 4 markers that just pop up everywhere. Now the first important thing is you have to use the keywords. If you're talking about rate of reaction, you're thinking about frequency of collisions. If you're talking about equilibrium, you're thinking about partially opposing. If you're talking about fuel cells, you're thinking about strongest oxidizing and reducing agents. And the next really big thing is being able to answer your specific question. Here's an example. A question might ask, why are fuel cells important? And another question might ask, why are fuel cells important on Mars? Do you see the subtle difference between these 2 questions? They're actually asking 2 pretty different things. One's asking in general, what is the benefits of fuel cells? The other is asking, why should fuel cells be used on Mars? What benefit do they bring to Mars? And so when you're answering a question like the second one, you have to be specific to the context that's given. You don't want to be blabbering about some bullshit, right? Or fuel cells are efficient, they won't contribute to greenhouse gas climate, blah blah blah. Or as you can tell now, that's an Earth related thing, that's not a Mars related thing. You want to be really specific to the context of the question. Have a think about why did they add this bit of context into this question? Like if they got rid of it, would I have answered differently? And 90% of the time, the answer is yes, you would. When you're reading questions, make sure to take care of the context that's given. Think about it as, you're not explaining the topic, but you're explaining the situation that's been given. And finally, with experimental stuff, usually it's not too bad until it comes to the evaluation of errors. Many errors can occur, but how do you fix it? Well, the number one generic answer people write is, so repeat your trials. That won't cut it. Again, it's not being specific to the context of the experiment. Your experiment is probably going to be something to do with calorimetry, something to do with titration, something to do with maybe like catalysis or something like that. So What's the point in saying repeated trials for both of them? It shows you how you don't have any understanding of the experiment at hand. What you've got to do, right, is consider your experiment and consider an error and a way to fix that error that is really specific to the experiment itself. For example, one of those calorimetry problems is that there's heat loss. So how do you fix that? You think of insulating the surrounding environment. Being specific to the experiment shows the examiners that you understand what you're dealing with. It gives them an excuse to give you the marks that you want. So I hope these tips were helpful to some degree, but if you're a VC student doing methods, I think if you click up here, there'll be a video about my math methods exam playbook that details some tips and strategies I used to go about that subject. But in any case, have a good one. Bye bye.